Now 5.7 is going to be dividing, but we're going to divide by a monomial. Monomial, remember, is one term. But before I look at polynomials, let me do a refresher or how we do fractions on real numbers. We have, for example, let's say I had 2 over 7 plus 3 over 7, right? When we add fractions, then we combine, since it's the same term here, we have a 7, we just copy it. And on the top, we do 2 plus 3. We can simplify to a 5, but that's basically what we do. Same term, we copy it. And then up here, we just combine it. Now, if this was a polynomial with a monomial, so that means I could have many terms on the top. As an example, let's say I had 5x squared plus 3x plus 5, and all this was divided by 7. So when I have something on the top with the same term here, I see that with numbers only, I can split it. So that's exactly what I'm going to do here as well. I'm going to do 5x squared plus 7, over 7, plus 3x over 7, plus 5 over 7. So I'm going to split it. I could have, if I have a fraction with the same term, I could split it into many fractions. That's why we learn how to do exponents in fractions at a previous section. Let's take a look at an example of what we mean. I'm going to divide this term by this term. So if we see what we mean, we have 5m to the 5th minus 10m to the 3rd divided by 5m squared. So I just said in the previous slide, to split this into fractions, I'm going to have 5m to the 5th over 5m squared minus 10m to the 3rd over 5m squared. And then treat each fraction at the time. Numbers-wise, coefficients-wise, 5 divided by 5 is 1. When it comes to exponents, subtract the exponents, remember? So I'm going to call this 1m to the 3rd. There's my minus in between. Numbers-wise, 10 divided by 5 is 2. Subtract the exponents, so I'm going to get m to the 1. And that's my answer. M cubed minus 2m. All right, let's take a look at another example. I'm going to rewrite this as 6p to the 4th over 3p squared plus 18p to the 7th over 3p squared. So numbers-wise, 6 divided by 3 is 2. Letter-wise, subtract the exponents, so I get p to the 2nd. There's my plus. Numbers-wise, 18 divided by 3 is 6. Letter-wise, I'm going to get p to the 5 because I subtract the exponents. Let's take a look at my example B. Let me rewrite this as 12m to the 6th over 6m squared plus 18m to the 5th over 6m squared, and then plus 30m to the 4th over 6m squared. So once again, I'm doing a polynomial. I'm going to separate it into many fractions, and I'm going to treat each fraction at a time. So numbers-wise, 12 divided by 6, that's 2. Letter-wise, m to the 4th, because I subtract my exponents. My plus, numbers-wise, 18 divided by 6 gives me 3. M to the 3rd, because I subtract my exponents. On the last one, 30 divided by 6 is 5, and m to the 2nd. Okay, so my last example, let's take a look at 18 r to the 7th minus 9r squared, and all these are divided by 3r. So first one, numbers-wise, 18 divided by 3 is 6. Letter-wise, I get r to the 6th. Minus, numbers-wise, 9 divided by 3 is 3. Letter-wise, I get r to the 1 because I subtract them. So this is what I get. There will be some, we're going to see it. What if my numbers cannot be simplified nicely? Like, see how my numbers were able to divide evenly? Like 30 divided by 6 was 5, 18 divided by 6 was 3. So some of them are divisible nicely. But what if my fraction had something like, let's say, 14 over 8, right? 8 doesn't go into 14, but at least I can simplify it, divide each by 2, and I will call it 7 over 4. So there will be some where our answer will have a fraction, at least simplify the fraction, and there will be some cases where the m is at the bottom as well. So we're going to see those examples in a minute. Let's see. Let's come up with this one. Let me rewrite everything as a bunch of fractions. So I have 180 x to the fourth y to the 10th over negative 30 x y squared. My second fraction, I'm going to include the sign here. I'm going to do negative 150 x to the third y to the 8 all over negative 30 x y squared. Then I have plus 120 x squared y to the 6 all over negative 30 xy squared. Then I have minus 90 xy to the fourth all over negative 30 xy squared. And lastly, I have plus 100 y over negative 30 xy squared. All right, so let's take a look at this thing. Numbers wise, 180 divided by negative 30, that should give me negative 6. X's wise, I'm going to have x to the third because I subtract them. When it comes to the y, I'm going to have y to the 8th because I subtract them. Now in the second term, negative 150 divided by negative 30, that should give me positive 5. When it comes to x's, I get x to the second, y to the 6th. My third term, 120 divided by negative 30, that should give me negative 4. When it comes to x, I have x to the 1 and y to the 4th. Now here, negative 90 divided by negative 30, that should give me positive 3. When it comes to letters, x and x basically cancel out. I subtract the exponents of 0, so they cancel out. When it comes to y's, I get y to the second. Lastly, my numbers here, 100 divided by negative 30, it's going to give me a negative, but at least simplify your fraction. That's 10 over 3. Right? I cannot do any better. When it comes to x's, there's an x at the bottom, so leave the x at the bottom. When it comes to y's, subtract the exponents, but remember how we used to say that when the bigger exponent was at the bottom, keep it at the bottom? So I'm going to keep that y at the bottom. So there will be cases where your answer will be fractions, and there will be cases where the letters are at the bottom as well. Remember, we subtract the exponents, but we keep the letter where the bigger exponent was.